Welcome back, everyone. Today we're talking big data, which is a pretty loose term that gets thrown around. So, what in the world is it? Let's check this out.
So we constantly produce a lot of data. For example, via social media, public transport, and GPS. But it goes way beyond that. Daily, we upload 55 million pictures, 340 million tweets, and 1 billion documents. In total, we produce 2.5 quintillion bytes a day. That's a lot of zeros. It's ridiculous. We call this big data. But what's actually more important is what you can do with it. To process big data, you don't need huge computers. People work with the cloud, an endless network of normal servers, and powerful algorithms. This way, they can analyze over 1 million pieces of data in minutes. And the result? Well, for example, video streaming website Netflix analyzed the big data of their viewers, like popular shows and watching patterns. This way, they produced a successful series with the perfect combination of actors, directors, and storyline. Right now, the big data of traffic is being analyzed to develop a car that can drive completely accident-free all by itself. And in the future, we can even use the big data of DNA to determine the perfect treatment. This way, curing genetic diseases like cancer would become much easier. And that's just the start.
So, big data is data sets that are so voluminous and complex that traditional data processing application software are just inadequate to deal with them. It's becoming increasingly easier and cheaper to obtain for several reasons. The internet. Okay, so we're using the internet every day, but you got to keep in mind, the internet in the grand scheme of things is relatively new. We didn't have access to this amount of data until recently in human history. The Internet of Things, and we got a little bit of a appendix here. Let's talk about this. Internet of Things is a network of physical devices, vehicles, home appliances, and other items embedded with electronics, software, sensors, actuator, connectivity that enables those objects to connect and exchange data. Give me some examples in chat. Internet of Things. There's some things that you probably are not quite thinking about that this incorporates. So these are things that aren't your computer. They are devices that we've embedded electronics into. And with these things in existence, we're actually able to get not only new types of data, but like a wide range of it. Our Samsung smart fridge, that is in this whole realm of Internet of Things, right? Something like a thermostat, absolutely, right? Amazon Echo. I'm going to lump Amazon Echo along with your Google Home into just this one category known as smart speakers. But what all of these devices are doing is that they are getting data, but it's new types of data in a lot of instances. For instance, like our thermostat is giving us temperature data about homes that we previously did not have. One that we're kind of missing here, a smart watch. I don't know why I'm pointing at this. There's just hair and skin. But a smart watch is giving us data about, like what heart rate, that sort of thing. That's really new in the grand scheme of things. But because so many people are wearing smartwatches, that is a new type of data that we actually have a lot of. And so Internet of Things is playing into this along with the internet. Like every device that connects to the internet, these embedded computers, we're still talking about Internet of Things, will have an IP address. So something like your thermostats, right? If you have like a Nest thermostat, I believe that's going to get an individual IP address. Something like a smart watch, however, is just using your phone. And so it's effectively using your phone's IP address. Regardless, they're connecting to the internet in some way, and so they'll have an IP address. A standalone device such as a cell phone or smart speaker may have its own IP address, while certain devices such as a smart watch will depend on another type of device. IoT, Internet of Things, is growing and deploying numerous information sensors, cameras, right? Think about all of the sensors that are in your cell phone alone. We're taking all types of picture and video. There's microphones embedded in those cell phones, right? So we're getting a lot of new data and just a lot of it. On this idea of Internet of Things and IP addresses, there's always a funny story that I kind of talk about, which is a couple of years ago, people were having issues with their crock pots because somewhere along the lines we decided that having a crock pot that is a slow cooker that's capable of connecting to the internet is a good thing. The idea is I can pick up my phone and see what the temperature of my crock pot is and tell it to turn off or turn on from anywhere in the world. The problem that we're having is the people that are making these crock pots are not putting in the same security protocols that are maybe in your cell phone. And so people were hacking in to crock pots and finding a way to get into local networks. So as a result, big data is growing and rapidly encompassing a wide variety of data types. One of the first areas where I kind of think of big data is Amazon. That's the one that really hit me. This idea of if you buy this, you might also like this. And that came about because there's so much data. In theory, okay, Thomas bought this thing. Now Daniel's buying it. What else did Thomas buy? On a small scale, that doesn't really make a lot of sense. There's just not enough statistics. There's not enough data there. Your sample size is too low. But when you're Amazon and you sell so much stuff, then yeah, the trend of person A bought this thing. What else did person A buy? Well, whenever person B goes to buy something similar, you can start recommending stuff. That's where that comes into it. And it's the big psychology factor, which I think is pretty interesting. The last and final reason that we're going to incorporate here as to why big data is really blowing up and becoming a big deal is storage capacity. Remember my lecture from yesterday? We're talking about how a lot of this stuff, including the internet, really developed in kind of the mid-90s. And in the mid-90s, storage capacity, that was a problem. In the mid-90s, Amazon's not really doing a good job of saying, well, if you like this, you may also like this. Because they can't. They don't have the capacity to do that. However, the world's technological per capita capacity to store information has roughly doubled every 40 months since the 1980s. Effectively, this is following a similar trend. That is, our storage capacity is following a similar trend to Moore's Law. If you actually kind of map those out. As of 2012, 2.5 exabytes of data are generated every day, according to our video that we just watched. And the IDC, the Internet Data Center, predicts that there will be 163 zettabytes of data by 2025. Realities are the vast majority of that data collected is garbage. So it's one thing to collect all of this data. It's another to analyze it. In theory, we're collecting so much data that most of it's just not worth anything. Or so we think, at least until it gets analyzed. So one of the things that's interesting from this is that we're starting to develop AI that is looking at big data. So these days, instead of Amazon saying, okay, well, person A likes this, person B should buy this similar item, yada, 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 that is trying to do that manually, just as a human looking through the stuff that people buy. It doesn't really work these days. There's just too much data. And so we're now starting to develop AI that is trying to look at big data and figure out trends. In the case of Amazon, buying trends, or in case of Netflix, watching trends. And what's interesting in this area to me is that the AI is finding out stuff that I don't think we would normally find out if we were just to manually go through it anyway. Kind of an analog I can draw to this is the AI that we have developed to play the board game Go, and the AI that we developed to play people at Dota 2. One of the interesting takeaways that the players experienced is that the AI would do things that was radically different from how humans were playing. right? They're developing new strategies that there's like, oh, this doesn't look right, but whenever the AI does it, it obviously works, right? It's good strategy. A similar thing is going to apply here. There's actually going to be trends within the big data that we wouldn't normally get to if we just manually tried to analyze it. So this is where big data analytics comes in, or like data science. Data science is this whole field. You could kind of put it under the umbrella of computer science because most frequently, like I said, they're not manually analyzing data. They're having to actually develop, algorithms or write code to help them analyze. So data science is absolutely exploding as a form, and you can either put it under the computer science umbrella, at least say it's computer science adjacent. I'm talking about data science. Big data analytics seeks to extract value from all of this. Analysis of this data seeks to spot business trends, prevent diseases, combat crime, predict user behavior, and so on. Okay. The rest of today is me watching this TED Talk along with you. It's super interesting, and I think you're going to like it. I'll pause it at intermediate parts, but let's enjoy it.
Roy Price is a man that most of you have probably never heard about, even though he may have been responsible for 22 somewhat mediocre minutes of your life on April 19, 2013. He may have also been responsible for 22 very entertaining minutes, but not very many of you. And all of that goes back to a decision that Roy had to make about 3 years ago. So you see, Roy Price is a senior executive with Amazon Studios. That's the TV production company of Amazon. He's 47 years old, slim, spiky hair, describes himself on Twitter as movies, TV, technology, tacos. And Roy Price has a very responsible job because it's his responsibility to pick the shows, the original content that Amazon is going to make. And of course, that's a highly competitive space. I mean, there are so many TV shows already out there that Roy can't just choose any show. He has to find shows that are really, really great. So in other words, he has to find shows that are on the very right end of this curve here. So this curve here is the rating distribution of about 2,500 TV shows on the website IMDb. And the rating goes from 1 to 10, and the height here shows you how many shows get that rating. So if your show gets a rating of 9 points or higher, that's a winner. Then you have a top 2% shows. That shows like Breaking Bad, Game of Thrones, The Wire. So all of these shows that are addictive, where after you watch this season, your brain is basically like, where can I get more of these episodes, right? So that kind of show. On the left side, just for clarity, here on that end, you have a show called Toddlers and Tiaras, which should tell you enough about what's going on that end of the curve. Now, Roy Price is not worried about, getting on the left end of the curve, because I think you would have to have some serious brain power into undercutting Toddlers and Tiaras. So what he's worried about is this middle bulge here, the bulge of average TV, those shows that aren't really good, really bad, they don't really get you excited. So he needs to make sure that he's really on the right end of this. And so pressure is on, and of course, it's also the first time that Amazon is even doing something like this. So Roy Price does not want to take any chances. He wants to engineer success. He needs a guaranteed success. And so what he does is he holds a competition. So he takes a bunch of ideas for TV shows, and from those ideas, through an evaluation, they select 8 candidates for TV shows, and then he just makes the first episode of each one of these shows and puts them online for free for everyone to watch. And so when Amazon is giving out free stuff, you're going to take it, right? So millions of viewers are watching those episodes. What they don't realize is that while they're watching their shows, actually, they are being watched. They are being watched by Roy Price and his team, who record everything. They record when somebody presses play, when somebody presses pause, what parts they skip, what parts they watch again. So they collect millions of data points because they want to have those data points to then decide which show they should make. And sure enough, so they collect all the data, they do all the data crunching, and an answer emerges. And the answer is, Amazon should do a sitcom about 4 Republican US senators. they did that show. So does anyone know the name of the show? Yes, Alpha House. But it seems like not too many of you here remember that show, actually. So because it didn't turn...
Okay. So let me just kind of highlight what Amazon's approach is here. They have 8 show ideas, basically, coming from 8 different producers, we'll say. And they produce only the pilot episode of those 8 ideas. Those pilot episodes go onto Amazon Prime, whatever their little watching service is called, and they're free. So anyone that has that can go in and watch those shows. So they end up getting millions of viewers to watch these 8 episodes for 8 different shows. And then from that, yes, a pilot episode, Battle Royale, from that they get enough data that they choose one of them to then turn into a show. This is Amazon's approach. Okay. Something else I do want to kind of touch on here, and what he said is Amazon is monitoring, when you pause, when you rewind, those type of things, episodes that get watched, multiple times. What's interesting here is those types of data points is actually the same type of stuff that Khan Academy is doing. So I believe Sal Khan has a similar TED Talk where he talks about some of the stuff that they're doing. And one of the things that really stuck with me is that they know when people pause. And when you're talking about something in the context of Khan Academy, what it tells them is maybe areas that are difficult. Maybe it's either A, a difficult concept, or B, their explanation wasn't good. If you have to pause and back it up, either the concept is difficult or their explanation wasn't very good. But they're able to get that data, and that's relatively new. And it doesn't matter if it's only like 3 people. Maybe those 3 people are just stupid. But when it's 3 million people, you get a trend out of it. And so that's the idea behind big data.
Turn out that great. It's actually just an average show. Actually, literally, in fact, because the average of this curve here is at 7.4, and Alpha House lands at 7.5. So slightly above average show, but certainly not what Roy Price and his team were aiming for. Meanwhile, however, at about the same time, at another company, another executive did manage to land a top show using data analysis, and his name is Ted Sarandos, who's the chief content officer of Netflix. And just like Roy, he's on a constant mission to find that great TV show. And he uses data as well to do that, except he does it a little bit differently. So instead of holding a competition, what he did, and his team, of course, was they looked at all the data they already had about Netflix viewers, the ratings they give the shows, the viewing histories, what shows people like, and so on. And then they used that data to discover all of these little bits and pieces about the audience, what kind of shows they like, what kind of producers, what kind of actors. And once they had all of these pieces together, they took a leap of faith, and they decided to license not a sitcom about 4 senators, but a drama series about a single senator.
You know what the show is? Help me out, chat. Amazon's approach was to develop these 8 pilots, and then from there, they kind of picked one. Netflix's approach is use their entire catalog. Use all of their shows, right? So they get a much bigger survey of information. And instead, kind of look for trends within the existing shows on what people like and try to engineer a show from that.
You guys know the show? Yes, House of Cards. And Netflix, of course, nailed it with that show, at least for the first 2 seasons. House of Cards gets a 9.1 rating on this curve, so it's exactly where they wanted it to be. Now,
so of note, House of Cards, starring Kevin Spacey. This was pre-Kevin Spacey child molestation stuff, but Netflix's data showed that people liked Kevin Spacey. And so they actually just handpicked him based off their data and made a show around him.
The question, of course, is what happened here? So you have 2 very competitive, data-savvy companies. They connect all of these millions of data points. And then it works beautifully for one of them, and it doesn't work for the other one. So why? Because logic kind of tells you that this should be working all the time. I mean, if you're collecting millions of data points on a decision you're going to make, then you should be able to make a pretty good decision. You have 200 years of statistics to rely on. You're amplifying it with very powerful computers. The least you could expect is a good TV, right? And if data analysis does not work that way, then it actually gets a little scary, because we live in a time where we're turning to data more and more to make very serious decisions that go far beyond TV. Does anyone here know the company Multi-Health Systems? No one. Okay, that's good, actually. Okay, so Multi-Health Systems is a software company, and I hope that nobody here in this room ever comes into contact with that software, because if you do, it means you're in prison. If someone here in the US is in prison and they apply for parole, then it's very likely that data analysis software from that company will be used in determining whether to grant that parole. So it's the same principle as Amazon and Netflix, but now instead of deciding whether a TV show is going to be good or bad, you're deciding whether a person is going to be good or bad. And as mediocre TV, 22 minutes, that can be pretty bad, but more years in prison, I guess, even worse. And unfortunately, there's actually some evidence that this data analysis, despite having lots of data, does not always produce optimum results. And that's not because a company like Multi-Health Systems doesn't know what to do with data. Even the most data-savvy companies get it wrong. Yes, even Google gets it wrong sometimes. In 2009, Google announced that they were able, with data analysis, to predict outbreaks of influenza, the nasty kind of flu, by doing data analysis on their Google searches. And it worked beautifully, and it made a big splash in the news, including the pinnacle of scientific success, a publication in the journal Nature. And it worked beautifully for year after year after year, until one year it failed. And nobody could even tell exactly why. It just didn't work that year. And of course, that again made big news, including now a retraction of a publication from the journal Nature. So even the most data-savvy companies, Amazon and Google, they sometimes get it wrong. And despite all those failures, data is moving rapidly into real-life decision-making, into the workplace, law enforcement, medicine. So we should better make sure that data is helping. Now, personally, I've seen a lot of this struggle with data myself, because I work in computational genetics, which is also a field where lots of very smart people are using unimaginable amounts of data to make pretty serious decisions, like deciding on a cancer therapy or developing a drug. And over the years, I've noticed a sort of pattern, or kind of rule, if you will, about the difference between successful decision-making with data and unsuccessful decision-making. And I find this a pattern worth sharing. And it goes something like this. So whenever you're solving a complex problem, you're doing essentially two things. The first one is you take that problem apart into its bits and pieces so that you can deeply analyze those bits and pieces. And then, of course, you do the second part. You put all of these bits and pieces back together again to come to your conclusion. And sometimes you have to do it over again, but it's always those two things, taking apart and putting back together again. And now the crucial thing is that data and data analysis is only good for the first part. Data and data analysis, no matter how powerful, can only help you taking a problem apart and understanding its pieces. It's not suited to put those pieces back together again and then to come to a conclusion. There's another tool that can do that, and we all have it, and that tool is the brain. If there's one thing a brain is good at, it's taking bits and pieces back together again, even when you have incomplete information, and coming to a good conclusion, especially if it's the brain of an expert. And that's why I believe that Netflix was so successful, because they use data and brains where they belong in the process. They use data to first understand lots of pieces about their audience that they otherwise wouldn't have been able to understand at that depth. But then the decision to take all these bits and pieces and put them back together again and make a show like House of Cards, that was nowhere in the data. Ted Sarandos and his team made that decision to license that show, which also meant, by the way, that they were taking a pretty big personal risk with that decision. And Amazon, on the other hand, they did it the wrong way around. They used data all the way to drive their decision-making. First, when they held their competition of TV ideas, then when they selected Alpha House to make as a show. which of course was a very safe decision for them because they could always point at the data and saying, this is what the data tells us, but it didn't lead to the exceptional results that they were hoping for. So data is, of course, a massively useful tool to make better decisions, but I believe that things go wrong when data is starting to drive those decisions. No matter how powerful, data is just a tool. And to keep that in mind, I find this device here quite useful. Many of you will. Before there was data, this was the decision-making device to use. Many of you will know this. So this toy here is called a Magic 8-Ball, and it's really amazing because if you have a decision to make, a yes or no question, all you have to do is you shake the ball, and then you get an answer, most likely, right here in this window in real time. I'll have it out later for tech demos. Now, the thing is, of course, so I've made some decisions in my life where in hindsight, I should have just listened to the ball. But, of course, if you have the data available, you want to replace this with something much more sophisticated, like data analysis to come to a better decision. But that does not change the basic setup. So the ball may get smarter and smarter and smarter, but I believe it's still on us to make the decisions if we want to achieve something extraordinary on the right end of the curve. And I find that a very encouraging message, in fact, that even in the face of huge amounts of data, it still pays off to make decisions, to be an expert in what you're doing and take risks. Because in the end, it's not data, it's risks that will land you on the right end of the curve. Thank you.
So, level 0 of this is just collect the data to begin with. And you'll actually see occurrences where people are kind of in that phase of collecting data. For instance, the smart speakers that people are voluntarily putting in their house. There is data that is to be gained from that, from anytime anyone uses the audio. But you'll actually see some moves that companies make in the name of just getting data. For instance, is Apple Pay. This is kind of one that I've noticed, where Apple is trying to get you to enter credit card information into their system, and then you could just use your phone to buy things. And that seems like a convenience. And the question is then, why does Apple want this? Because you got to keep in mind that on the back end, Apple has to store all that data. They then also have to make sure that it's secure. And so why would Apple actually put forth an expense, right, just to get people to have their credit card data within Apple's system? They're not turning around and selling that. I mean, they shouldn't be. They're not turning around and selling that. But what it allows them to do is actually track things like spending. And it's not really a breach as long as they don't. It's not like a breach of user trust or client trust if they go out, as long as they don't sell that information. As long as Apple doesn't sell the information about what you're buying, as long as they're only using it internally, then that's theirs, and you have voluntarily given that to them by signing up for Apple Pay. My point is they're doing that in the name of data collection. So that's kind of level 0, is just collect data. The next level is let's analyze that data, and that's where data science comes in. Now it's a lot of data, and so that tends to be program based, and as I said, that's moving towards AI. And then so once you have the data and you start analyzing it, then you start making decisions. So level 2 here is making decisions off that. And what he is saying here towards the end is that you can blindly make those decisions, right? If we produce AI that analyzes data, big data, and then comes to a conclusion, and if we were to blindly follow that conclusion, we would sometimes end up with pretty negative results. But what's interesting is if we make this leap of faith, if the AI is able to analyze big data in a way that we would not normally, and come to a conclusion that we would not normally come to, we then have to use our brains to decide, is that conclusion a good one or not? And I don't necessarily think that that is an easy decision to begin with. We're going to wrap it up there, guys. Thank you for tuning in. This has been Big Data. I had questions about how does the Magic 8-Ball work. I believe there's 12 responses. So it's like a 12-sided die in there. And when you shake it, it's just inside of this goo. And that helps it slowly turn. It turns to one side. All right, let's chill.